Welcome to this episode. Today we're going to talk about grouping and facets and how we can compare data across different categories. So let's just switch over to some slides. You saw in the previous episode that Matplotlib can do some forms of small multiples, so it can plot out a grid of plots from different groupings in data. It's quite hard, particularly in JupyterLab, to make this work well. You have to resize the canvas that it works on. And an alternative is to use Seaborn, which is one of the other visualization toolkits that sits on top of Matplotlib. So we're going to try and do that here and show you how that works. You'll not need to use Seaborn necessarily in the course, but if you come across this problem, it can be a good solution. So if we check that this works, that's fine. We've imported pandas, we've imported Matplotlib, and now we've imported Seaborn, and the standard summary for that is SNS. If you're installing Seaborn, I've found that it can be better to install it by uninstalling Matplotlib and pandas first, and then installing Seaborn, which will then pull in all the libraries it needs behind that. If you don't do that, I've found sometimes it can't find DLLs and things, so that's a quick tip on using it. This reads in the file that we used previously, satdf. Let's just check it's there. And there you go. You can see the categories across the top, low, medium, high, and very high, that people voted for in terms of their life satisfaction. The values for each in terms of the percentage of people who voted for each category. And then the second category here is area names. And these all come together in one quite compact data set here. It turns out that this structure isn't very helpful for visualization always, and many packages would prefer it in a flattened structure or an unpivoted structure. I'll show you what that means now, because we'll need that today. The first thing I need to do is extract from the dataset the category names for the life satisfaction categories. So let's do that across the columns. And if I type in this ordinals, you'll see that's brought low, medium, high, and very high. Here is how we're going to turn this into this flattened structure. I'll show you it when it's finished, but we're going to use a pandas command called melt. And what that will do is take all of the low, high, very high, and high values and create a single row for each one. So each row will have just a single measure in it. So let's just show you what that is. And there you go. So you've got the area names, you've got the variables now, which is the ordinal, and the value for each one. So in the Northeast, 6.43% of people voted for low. And you can go all the way down and get down to the last one with very high. So that's a flattened data structure. It is often, not always, a very good way to read data into manipulation tools like pandas for visualization, like Power BI we'll see later in the course. Okay, so that's the flattened structure. And once we've got that, it's really very straightforward in Seaborn to plot that. So the command we're going to use to create this small multiples layout is facet grid. And I'll just run it here and you can see it empty. So we've got 9 plots today, which are the 9 regions of England, and each one's going to have its own plot area. So that's created the facet grid. So if we add on the bar plot, you'll see it plots for each of the facets, each of the regions in the data, the variable, which is the life satisfaction, and its score, so its percentage of agreement with that variable. It'll be easier to run it and see it working. Got the Northeast, the Northwest, Yorkshire, East Midlands, West Midlands, East of England, London, and the Southeast. Okay, so that's somewhat informative, but not totally, because we don't know what the columns mean. So we're going to add a legend to this, and we'll add a title as well. So now with a legend and a title, you can see what's happening. We've got low, medium, high, very high across the x-axis, percentage agreement across the y-axis, the title across the top, and we've added a legend, so there's also a color code. One thing you will see is almost all the areas have a very similar spread. There are small differences in how many highly satisfied to lowly satisfied people there are in each region. So that's an organization of the data by small multiples, and the small multiple variable is region, area of the UK. It's good for comparing the shape between the regions. But what if you want to compare the values side by side? Well, there is an alternative way to use it, using a categorical plot. So we're going to use cat plot this time, categorical plot. We give it the same data, the same flattened data structure, and I said that was useful, so it's useful again here. We're going to use a bar chart. X is going to be the variable, Y is going to be the value, and the color is going to be the region. So variable is the categorical variable, in this case this ordinal scale, value is the percentage agreement. We run that again, so now you'll see we've grouped the data differently. It's a single plot this time, and we've got all the regions in each of the 4 levels of the ordinal variable. This allows you to see the trend between regions more easily. Okay, so that's the end of a quick introduction on faceting and grouping data in plots. There are many tools for doing this, and as I've tried to illustrate here, it depends what you want to compare against what. If you want to compare shape, distribution across these 4 categorical levels in an individual region, it would be much easier to do it in the faceted plot. But if you want to compare within a level across regions, this type of plot is much easier. So you do need to understand your message, your user's intent in using the data, to understand which type of plot will most easily help them understand what's there. Okay, well, thank you for watching, and I'll be back with another episode soon.